A commonly asked question when it comes to consumables for Powermax air plasma systems is, when is it time to change them? While some consumables, like the electrode and nozzle, display more visible wear, other consumables, such as the swirl ring, may not be so obvious. In fact, we have had customers who didn't know you had to replace the swirl ring. So in this section, we will cover what to look for to know when it is time to replace the swirl ring. The main function of the swirl ring is to control the swirling action of the plasma gas flow around the electrode. It does this to center the arc on the electrode and through the nozzle, and constrict the arc for faster cut speeds and thicker cut capability. The swirl ring has small angled holes, and on certain versions, an O-ring seal. They are typically made of plastic. Some of the common swirl rings are shown here. Some processes require the use of a specially designed swirl ring to achieve the desired application outcome. The quality of the cut is highly dependent on this flow pattern. During electrode and nozzle changes, you should inspect the swirl ring for damage, such as cracks, deformations, and clogged holes. Replacement is needed if any of these issues are found. Standard use indicates swirl rings should at least last through 15 electrode and nozzle changeouts, but this can differ depending on usage patterns. When assembling consumables onto a torch, it is important that the swirl ring is positioned correctly. We recommend referencing the consumable label on the power supply or the operator manual to ensure you have positioned the parts correctly in the consumable stackup. The electrode is a consumable that most users let go past the normal usage point, and that can cause a blowout, a catastrophic failure of both the electrode and nozzle. The following section will cover how the electrode functions and how to avoid overuse to ensure optimal cutting performance. The primary function of the electrode in any plasma cutting torch is to provide power to the plasma arc. It is the starting point and electrical contact point of the plasma arc. The Powermax family have 5 basic electrodes that are shown here. One of the main features of the electrode is the plasma arc attachment point. The attachment point is a small cylindrical insert in the tip of the electrode, made of an element with a very high melting point such as hafnium. This insert must withstand the extreme heat of the plasma arc. Now, let's take a close look at that insert. As it wears, the insert will slowly erode, forming a small pit in the center of your electrode. Hypertherm recommends that you change your electrode when that pit depth measures 1 mm or 40 thousandths of 1 inch. Here are some key cues to alert you on when to inspect for consumable wear. If you need to slow down considerably or are not able to cut through material. Green discoloration of the arc or fumes. Excessive dross appearance. The arc is misfiring or difficult to start. It is a common recommendation to replace both your electrode and nozzle at the same time. This will ensure optimal cut quality and will help eliminate any guesswork on when to replace. The nozzle is one of the most commonly changed consumables in the stackup. Proper inspection and replacement is needed to ensure optimum cut quality. In comparison to the electrode, which carries the electrical current, the nozzle does the important job of focusing the arc by funneling gas flow. Nozzles are designed with different sized orifices depending on application and amperage. For example, a gouging nozzle has a wider orifice which results in a wider, less defined plasma arc. This is effective in gouging applications where the goal is to remove layers of metal as opposed to attaching and cutting through the metal. As the nozzle is used, it takes the brunt of the heat during the plasma process. As a result, the orifice eventually widens and the arc can become wider and less constricted. The kerf, which is the width of metal that you remove during the cut, also gets wider and wider. In addition, your cut speed becomes slower because your arc isn't as concentrated. If you are observing performance issues, it is a good idea to inspect the nozzle. Regular inspection of the nozzle should focus on the size and shape of the orifice. You should replace your nozzle anytime your orifice shows the following signs: nicks or notches, an out of round or oval shape, or rounded edges. In addition, if replacing your nozzle, we strongly recommend that you replace your electrode at the same time. Another factor that impacts nozzle life is proper gas flow. Low flow rates can lead to catastrophic, almost immediate nozzle destruction by causing the pilot arc to attach to the inside of the nozzle orifice. Check to make sure that you have proper gas flow if you feel that you are experiencing premature consumable life. In this section, we will discuss the retaining cap and what signs to look for in terms of wear and replacement. The retaining cap's primary function is to hold the swirl ring, electrode, nozzle, and shield in place to ensure proper alignment. Holes inside the retaining cap aid in directing shield flow gas, provide cooling for the consumables, and assist the cutting process. When inspecting the retaining cap for wear, it is essential to inspect the threads. Dirt will damage threads over time, requiring the cap to be replaced prematurely. The retaining cap also protects the consumables from outside impact and excessive heat exposure. During standard cutting operation, the retaining cap can typically last through several electrode and nozzle changeouts. For gouging applications where the arc is on for longer durations, heat exposure can melt or deform the retaining cap. Look for areas on the retaining cap that look worn due to heat exposure. While the nozzle and electrode are the most commonly changed consumables in the stack-up, the shield needs to be changed on a regular basis as well. Shield shapes will vary by the application they are designed to address. There are a few different types of Powermax shields. Drag shields that are isolated can be dragged on the plate and against a template or guide. Mechanized shields are also available for automated applications. Additionally, there are different shields for fine cut, marking, and gouging applications. The shield has several important functions. The shield protects the other consumables from molten spatter, especially the nozzle. The drag shield's castellation sets the torch height so that the flattest part of the arc is cutting the metal. It helps cool the nozzle. It contributes to good cut quality and faster cut speeds. And when using a hand torch, the shield enables drag cutting. The shield has a main orifice that aligns with the nozzle orifice and may have additional vent holes around the center. The most common issues associated with the shield are damage to the main orifice or clogging of the vent holes. Both issues can cause performance problems. It may become evident that the shield is wearing when you spot signs of dross around the orifice or the castellation is worn. Sometimes you can easily pick or brush the dross off the shield with a wire brush. If the orifice is still perfectly round, then the shield can still be used. If not, the shield should be replaced. To learn more about Powermax consumable information, please go to hypertherm.com using this URL address. Thank you for watching.